Good afternoon, everyone. Today we are going to have a look at a new category of neural networks, which are called recurrent neural networks. These are slightly different from the traditional neural networks that we have seen so far. The main difference being that these kind of networks are able to have a memory, because of which these neural networks are able to learn temporal and sequential patterns. Uh, Basically, the idea is that you can use these type of networks to learn sentences, words, etc., etc., and that is why you will find variants of recurrent neural networks being very widely used in applications like natural language processing. Let's get into the topic, and we will go and try to explore a little bit about what recurrent neural networks are and how they work. So the first problem that we have with the convolutional neural networks that we have seen so far is that you do not have any temporal dependence on the inputs and the outputs. For example, you give an input, it gives you an output. You give a second input, it gives you a second output, but the inputs and the outputs are not assumed to be correlated with each other in any way. So that is the basic problem that you have with CNNs or any neural network based classification algorithms, because they traditionally don't seem to take temporal dependence into account. Sequence learning, on the other hand, requires you to have a memory of what happened in the past to predict what is going to happen in the future. So an example is given here. You can see this concept is very similar to what you will find when you're trying to read a book. Okay, you need to have a memory of what you have heard or what you have studied previously in order for you to understand what is going to come in the next few pages. So that is the idea of a sequence learning. Typically, if you look at recurrent neural networks, they are kind of abbreviated as RNNs. So if you look at RNNs, the RNNs are typically configured uh, like uh, this. So you will see that there will be an input, there will be an output, and there will be a feedback mechanism built into it. So there is a kind of feedback which contributes to the memory of the network. So the network is able to remember what it has seen previously, and using that as an additional input, you can see there is an input like your normal neural network, but there is also a feedback which is delayed. That is, there will be a step delay, usually one step delay between the feedback coming into this. So you have the input at any given instant coming in and the feedback from the immediately previous instant, which is also coming in as another input. So the system is now able to remember what it has seen at time t. It's also able to get as input what it has seen at time t equals to t minus 1. So that is the basic idea behind the recurrent neural networks. And there are several variants of this neural network. So you can see the first type is a typical one-to-one neural network. In one-to-one neural network, what happens is that you give an input and you immediately get an output. And there is a third input, which is called the initial state input, and that goes into the system and it behaves typically like a traditional artificial neural network. There is not much of a difference between this configuration of an RNN and your traditional neural network. Second option that you have is one to many. In this one to many type configuration, what you have is you have an initial input sequence which is given to the system. It results in an output. That output is fed back as input in the next time instant to the same network. Please remember what you are seeing here are not different networks. They are the same network at different instance of time. So you can see here, that is why we have given it as 1, 2 up to ty. So you have only one input at tx equals to 1, and you have multiple outputs which are coming in at different instances of time. So whatever you give as input at the first time instant becomes the output of that input becomes the input at the next time instant. The output that it generates at the second time instant becomes the input to the same network at the third time instant. So this is actually spread over time, and you just give one single input and the system itself generates multiple outputs of the total length ty. One very common example, or one very useful, or one very funny example that you can think of is that of music generation. So this is one available implementation of one-to-many learning using recurrent neural networks, where they have tried to generate music by using a very small seed input as the input to the network. So you give a very small input to the network, and the rest of the music the system will generate automatically. Okay, so that is one example of one-to-many outputs. The third example that we can see is many to one. In this case, what happens is you give an input which is spread over a period of time. The network consolidates the meaning of all those inputs and gives you an output, which is usually a single output, which is like maybe a class or maybe a probability. So you can see an example of that, which is you are trying to talk about rating a movie. So you can see here the input to the RNN, which classifies the sentiments based on the movie reviews, is like this. The input will be, I love this movie, I have seen it many times and it's still awesome. I goes in at time instant 1, L goes at the second instant, O goes at the third instant, V goes at the fourth instant, E goes into this at the fifth instant, and so on. Or if you are looking at word wise separation, you have I going at the first instant, love goes in at the second instant, this goes at the third instant, movie goes at the fourth instant, and so on. So this whole uh, paragraph is input to the network, and at the end of the last input the system generates an output saying that the sentiment is positive. In the second case, you have a paragraph which says negative things about the movie. So what will happen is that it will the network will take in the inputs one at a time sequentially, because as you type along, that input is going into the network. I type this, it goes as input 1. I type movie, it goes into the second input. I say is, it goes as the third input, and so on. It keeps on going. And as soon as I complete the sentence and press enter, my system gives me an output saying that the review was negative. So that is one example where you have a many to one type of an RNN. There are many inputs, but there is only one output, yes or no. So that is an example of many to one input. Second case, or the fourth example that we are seeing is many to many. So in many to many type of RNN configurations, what we have is the example being name entity recognition. In name entity recognition, what happens is that you can train the system to identify important parts of a speech or important parts of a text. So you can see the example here that we have picked from this source. Uh, you feed the two paragraphs into the recurrent neural network that you have already trained, and the system automatically tells you that Sebastian Thrun was a person. A, you worked in Google. 2007 is the date. Again, there is a person's name, date is earlier this week, less than a week, less than a decade later. All these are dates, persons, etc. So you can actually find out or pinpoint name, entities, years, dates, etc., etc., can be pulled out as and when we give as the input. So tagging of different components of a speech or a text is possible using many-to-many type configuration. The next one that we can talk about is many-to-many configuration, in which case you have the input sequence length and the output sequence length being different. All right. So you can see the common example being machine translation. That means you give an input which may have multiple words. You may get an output which has got different number of words. In this particular example, you can see it's accidentally happened such that you have 4 words as the input and you get 4 words as the output. But there could be languages where what is your name can be expressed in say 2 words or a one single word. In that case, it becomes a many to many translation where you give what is your name, that is four inputs as the input sequence, and you get maybe 2 words as the output sequence. This is commonly found in examples like machine translation, and that is what uh, typically many to many type networks are used for. And there are certain other configurations also. These are specialized configurations and slightly more complicated to train because they require a lot more computational resources than your traditional RNNs. So the examples are bidirectional RNN, in which case you have the training happening both ways. In traditional RNNs, you start from the earliest in time and move towards the latest sample in the forward pass and train or update the weights based on the latest example and move back into time. It's based, the training algorithm is called back propagation through time. So you can understand what it actually implies. You back propagate through time to the earliest sample that came. That is your traditional RNN. In bidirectional RNN, you begin to move both ways, which means that you propagate the error both forward and backwards. So in bidirectionally, that's what you are able to see here. The propagation happens in both ways. So this is the property of bidirectional RNNs. The only requirement in this particular type of RNN is that the entire sequence or the entire paragraph that you want to maybe translate should be available in at the time of the training itself. That means you cannot go along typing when the bidirectional neural network is requiring an input. You have to give the entire data set as the input at the same time because it needs the sequence input at the earliest time and at the latest time at the same time instant. So you should already have the speech or the text ready, which you can directly feed in at one shot, and then it will train and learn faster. The last type is deep RNN. Again, as you can see, it has got multiple layers instead of a single layer. And because of this, it is a lot more complicated to train and uh, requires huge amount of computational resources to make work properly. But these are very effective in doing almost all types of NLP type. So in the next video, we will try to find out why do you actually need RNNs and is there any other possible way. So please watch out for the next video. Thank you very much.